Hey guys, let's do this problem right here. Here this question is asking to find the amount of heat radiated from the sun, and also by the time it reaches the earth, what's going to be the intensity of that heat energy. Now here to find out radiation heat transfer rate, we have to use this equation. Q dot is equivalent to emissivity times sigma times surface area times temperature power 4. Sigma is Stephen Boltzmann constant. Now let's see whether we have all the informations. We have emissivity for the sun is going to be always 1. Stephen Boltzmann constant, that's the constant that will always remain the same, we know that. And a surface area for the sun. Sun is a spherical shape, right? So the surface area we're going to use for 4 pi r square. So that's going to be the surface area equation for a spherical shape. Now temperature, we don't have the temperature, but in this case what we can do is we can use Wayne's law. Wayne's law states that any radiating object we can calculate the temperature using this equation, that is 0.0029 divided by its wavelength. And wavelength for a sunlight, it's going to be 500 nanometer, so this is going to be divided by 500 nanometer. 0.0029 over 500 times 10 to the power minus 9, nano is 10 to the power minus 9 meter, and if you find this one out, you will get 5800 Kelvin. So this is the temperature we are going to plug right here. Now let's go ahead and plug all the values. First we have emissivity, that is 1 for sun, and Stephen Boltzmann constant is always going to be 5.67 times 10 to the power minus 8. And surface area for a spherical shape is going to be 4 pi r square, 4 pi times the radius. So here 4 pi r square, so radius is given right here, so we can use that one. 6.96 times 10 to the power of 8 square times temperature power 4, that's 5800 Kelvin power 4. And if you plug all these values in your calculator, you should get 3.6 times 10 to the power of 26 watts. Now the next question is asking what's going to be the intensity of this heat when it's reached the earth. To find this one out, we have to use this equation, that is intensity is equal to power over area, right? And if you notice, Q dot is power basically, because that's also watts and power also watts. So how much energy released per second? So that's the power. Now we can use this information. And area. Area is going to be again 4 pi r square, but in this one we have to use the distance between sun and the earth. So that's the one we are going to use. Now let's go ahead and plug the values. P is going to be 3.6 times 10 to the power of 26 watts divided by area, that is 4 pi r square, and the distance from sun to earth is 149 billion meter, so this is going to be 149 times 10 to the power of 9 meter square, and if you calculate this one, you should get 1290 watts per meter square, and that's going to be the answer for this question. I hope it helps. See you next time.